Okay, chapter 15, day 2. What we're going to talk about today is something called a normal distribution. It's an introduction here to statistics. Data in life around us a lot of times follows something called a normal distribution. If we read what it says here, it says certain data when graphed as a histogram creates what they call a bell-shaped curve because the inside of it looks like the inside of a bell, known as a normal curve or normal distribution. They are symmetrical, have a single central peak, that's their mean. Now, what do we know? Underneath the whole entire curve, we'll call that 100% of the distribution. So 50% of the distribution lies to the left, and 50% lies to the right. So if we were to graph data, real data, maybe like about your head circumference, some people are going to have smaller heads, some people have larger heads, and a lot of people are just right here in the middle. If I graph heights, the same thing's going to come out. There's some people that are shorter, some people are taller, a lot of people are right here in the middle. So we use this curve anytime we feel that data could potentially follow a normal situation. And also, it follows another pattern in which if we go out one standard deviation each way, in general, we have a certain percent of data that will fall within one standard deviation. So what this chart is, these are standard deviations marked down here. If I'm in the center, I'm no standard deviations away from the mean. I'm at the mean. As I get higher, I'm one standard deviation away, 2 standard deviations away, 3 standard deviations away. And if you look, the height of the bar represents about how much data. There isn't hardly any data beyond 3 standard deviations. Only 1/10 of 1% fall. These would be, like if we're measuring height, the extremely tall people. Okay? Same thing down this way. I could go under the mean, and I use a negative on my standard deviation to go under. 1, 2, 3 standard deviations. So these would be the very, very short people for a certain age. And so this general rule of thumb of the way the percentages fall is what we're going to use as a ruler to decide what percent of the data should fall theoretically between certain regions. Okay? So if you add the percentages up, you'll see that approximately, if I go down 1 to up 1 and add it up 15, 19.1, 19.1, and 15, you'll see that's about 68.2% is within 1 standard deviation. Okay? Within 1. If I keep going, you may say, well, what are these halves? Well, the chart is breaking them up into smaller increments, but we can focus for now just on the big numbers like 1, 2, 3, all right? So if I go down 2 and up 2 deviations, then this whole region here is around 95. It's 95.4% approximately within 2 standard deviations from the mean, okay? And if I go out to 3 standard deviations each way, I've accomplished about 99.8%, which is almost everybody or everything, whether I'm measuring the length of a tree frog, how many breaths per minute a fish takes, whatever we're measuring, it will generally follow this pattern if we consider it to be a situation that is normal, okay? So, when you see the words normally distributed, when you see those words, sketch the normal curve. You're just going to make a line, and then you're going to go a curve up, a curve down. It's not going to be perfect, but here you go. Sketch a normal curve. Label any information along the bottom of the curve. So what you want to do is in the center, okay, in the center, it would be where the mean is at 0 standard deviations. You'll label maybe how much that is if they give you the mean, all right? and then use the percentages to answer. Well, what I like to do is I label 1, 2, 3 standard deviations in each direction. Okay? So when I make a sketch, it'll look something like this. So let's take a look at this problem, for example. The national mean for verbal scores on an exam was 428. So they're telling me that the mean is 428. Standard deviation was 113, all right? Standard deviation, 113. Approximately what percent of those taking the test had scores between 315 and 541 if the exam are normally distributed? Okay, so they said that it might be normally distributed. And so what am I going to do? I'm going to draw my normal curve. Again, it's not the best looking thing in the world, but I know my mean has to be right in the center. 4, 2, 8. And then I'm going to go 1, 2, 3. Negative 1, negative 2, negative 3. Now, you might say, well, they use halves. We start with these, and then if we need to do halves, we'll do halves. Otherwise, you get too many lines on there, and it's too hard to read. So I'm going to add this amount to 428 to get my next number. So 428 and 113 would be 541. And if I add another 113, it's 654. And if I add another 113, I get 767. All right, so now I'll go backwards. 428 minus 113 would be 315. Take away 113 would be 202. Oh, squiggly. And if I take 202 and I take away another 113, okay, 12 minus 3 is 9, I get 89. All right, so I lay out my picture. And now let's ask, what do they want to know? Approximately what percent of those taking the test has scores between 315, okay, so where's 315? That's this one, all right? So this is 0 standard deviations. This is -1 standard deviations, -2, -3. This is 1, 2, and 3. I label my deviations. So 315, that's at -1 standard deviations. All the way up to 541, that's at +1 standard deviations. So I'm going to shade the region that I'm talking about, which is from -1 to +1. And now I use my chart. You will get this chart when you take your test. Any test or any assessment you take, you'll get this chart. So I'm going to go from -1 to +1. I can't stop at the first line because that's not -1, that's a half. -1, so I got 15, and I'm going to go all the way up to +1. So I got 15 plus 19.1 plus 19.1 plus 15. Okay, so I have 15 plus 19.1 plus 19.1 plus 15. Well, that is 68.2% when I add all those up. Approximately. So, just to recap, all right? Just to recap. Your job, anytime you see the words normally distributed in a question, draw a normal curve, lay out the center, 1, 2, 3, 1, 2, 3 for starters. So I laid out from the mean and a deviation. I added this 1 time, 2 times, and 3 times, and I went backwards, okay? And then I go back to the question. What do they want? They want 315 to 541. 315 is here, 541 is here. I'm going to shade what they want. Now I go find it in my chart. All right, I got to go from -1 to +1. So in my chart, from -1 to +1, I just add the percentages. Okay, let's take a look at one more question. All right. The amount of juice dispensed from a machine is normally distributed. Oh, normally distributed. I'm going to draw my picture first. First thing I'm going to do, draw a picture. Mean of 10.5, I can put that right in the middle. You might say, well, it's not quite in the middle. It's good enough. All right, 1, 2, 3, 1, 2, 3. Standard deviation of 0.75. So 10.5 plus 0.75, that's 11.25. And this is 12, and this is 12.75. I guess squeezing that in there. 0.75 from 10.5. All right, so that would be 9.75. And then 9, and then 8.25. Okay, so I draw the picture, and then I'll go figure out what they want. Which interval represents the amount of juice dispensed about 68.2% of the time? All right, so I got to go back. 68.2%. I know that is within one standard deviation, so you're going to want to memorize these numbers. Within one, which means down one and up one. So if I go back to my question, if I go back one, again, this is 0, this is -1, this is +1. So that would be from 9.75 to 11.25. Choice 3. And all of these questions kind of revolve around this scenario. Okay? The one thing, too, that you have to know is this word percentile. If you notice this next question, see it says percentile? All right? Percentile is all the percents at and below a given point. So, if I want to know what percentile I am, all right, then I look at my chart, and no matter where I mark, it would be everything at and below is a percentile. So if I'm in the 5th percentile, I'm way down here with only 5% below me. If I'm in the 50th percentile, I'm in the middle. If I'm in the 80th percentile, I would be way up here. Everything below me would be 80%, at and below. All right, and you'll need that as you do some of these questions. I know that's a definition you had probably in middle school, but you haven't seen it in a long time. So in class, we're just going to work on these problems.